going to talk about special products. The first one we're going to talk about is squares of sums and differences. Okay? So if I have something like x plus 5 quantity squared, I could easily do FOIL. I could do the quantity x plus 5 times the quantity x plus 5. Okay, and do FOIL, and I'd get the answer. But what I want you to do is learn and recognize these special products, because you're going to need them later when you are factoring and simplifying rational expressions. So, when you have some binomial that's squared, you are going to square the first term. So you can even write square each term. So I'm squaring x, and over here I'm squaring the 5, which is 25. And in the middle, you are going to multiply the terms together. And then multiply by 2. Okay, so the terms, if I multiply them together, are 5 times x times 2 is 10x. So if I were to have FOILed x plus 5 times x plus 5, I would have gotten x squared plus 10x plus 25. But because I know that they're both exactly the same binomial, and it's squared, I can square the first term, square the last term, multiply the terms together and double them, and you will have your FOILed polynomial. So let's try this one. Let's say it's 2x plus 6y squared. So we're going to square each term, and I'm going to get 4x squared and 36y squared. Now I'm going to double the terms. So I'm going to multiply them together. 6 times 2 is 12, times 2 is 24. X, y. Okay? So now let's try another one. Okay, and I want you to try this on your own. Try that one on your own. All right, so we are going to square this, and then we're going to multiply those together and multiply by 2. So 3 times 4 is 12, times 2 is 24, and we are done. Is the difference of squares the next product we're going to talk about, special product. Difference of squares, this is extremely common. And it's something you need to learn as soon as possible to recognize. It will make your life easier and your work will be more accurate. The difference of squares. When you have two binomials, like this, a minus b times a plus b, they have the exact same terms, but there's one of the binomials is minus and one of the binomials is plus. Okay? You are going to square each term. And you're going to put a minus inside of it. You're going to square each term and you're going to put a minus inside of it. So if I'm going to go backwards, okay? I'm going to go backwards, and if I had 4x squared minus 9y squared, and I wanted you to factor that, that would be 2x minus 3y, 2x plus 3y. Okay, so when they're two quantities squared, you're going to break them up like this. They're going to be two binomials with the same terms, and they're going to have different operators inside of them. If you start out with one where you see that you've got a perfect square, 4x squared, and another perfect square, and you have a minus, you'll break them up into two binomials with the square roots. So the square root of 4x squared is 2x. The square root of 9y squared is 3y, and you just have different signs in them. So let's practice. So I'm going to give you what will be that particular trinomial without doing FOIL. Think about what the answer will be on that product. So what you're going to have is 9a squared minus 25. Yes. And if you were to do FOIL, you would see that that's true. We have 9a squared minus 15a plus 15a minus 25. These cancel, and you have 9a squared minus 25. So when they give you two binomials with the same exact terms, but one's a plus and one's a minus, your answer will be the term squared with a minus. It's the difference of squares. So if I were to give you this problem right here, 3a minus 2 quantity squared, that is the difference, the product of sums. The product of sums. So with this one, we are going to square the first term. We're going to square the second term. And we are going to multiply together 6a times 2, 12a. And this sign right here always takes this sign. Okay? I'll FOIL it for you to see. (3a times 3a is 9a squared. 3a times negative 2 is negative 6a. Negative 2 times 3a is negative 6a. negative 2 times negative 2 is positive 4. So we double this, and we end up with the 12a. And we have this squared and this squared.
So,
okay? So this is just an easier way to do these problems, but it's also important to recognize because eventually you're going to get this in a problem, and you need to see that you've got a perfect square here, a perfect square here, and if you take the square roots and double it, you end up with this term. Square root of 9 is 3, square root of 4 is 2, 2 times 3 is 6, doubled is 12, and that's what you're getting in the middle there.
I get this now.
Okay? So now let me do this one. We have 25x squared minus 1. Is that the sum, product of a sum, or is that difference of squares?
Product of the sum.
Product of
Oh, I think no, wait.
No, product
No,
of
no,
the
it's
square.
squared.
Product of the square.
No, product of the sum.
Neither.
It's difference of
Yeah,
squares.
that's it.
This is a perfect square.
Minus 1.
Perfect square, right?
Yes.
What's the square root of 25?
5.
And x squared? X.
X.
Minus, what's the square root of 1?
1.
5x,
Squared plus 1.
right?
Yes.
Now, let me give you this one. Okay, so what will be the product of those binomials? That's called
16q squared minus 9.
Minus 9.
You got it. That's the difference of squares. So when, so let's try this one.
Yeah.
What's that one going to be?
4a. The 4a.
Squared minus
4a squared.
4
Plus
squared
1 plus 1.
How about 4a?
Oh.
And then minus 6.
Oh, yeah, 4a.
Minus 2.
Okay, because we square this one and we square this one. So we got 4a squared and we have 1 because we squared each term. Then this times this, 2 times 1 is 2, and then you double it, it becomes 4. Okay?